So, hello, welcome to the next class of coordinate compound. I hope last class you have seen the coordinate compound and you have studied. So, today we are going and further moving in this class. So, you can make a note type of salts here. So, types of salt. Okay. In that first salt is simple salt. Okay. Then next you can write down mixed salt. Then third you can write down double salt. Okay. Then fourth you can write down 1, 2, 3 complex salt. Complex salt, and this complex salt, in this type of a complex salt only coordinate covalent bond is seen, so I can say this coordinate salt also. Clear? Chalo. So first make a note this, then go with one by one simple salt. Okay. Clear? Now see, what do you mean by simple salt? A simple which you have seen at your home, NaCl, this kind of a salt we say as a simple salt. The salt which contains only one type of cation and one type of anion only. Okay, it contains only one type of a cation or it contains only one type of anion. So this type of a salt we say as a simple salt. Clear? Example: NaCl, KCl, KBr, NaBr, Ki, etc. Clear this part? So this type of a salt we say as a simple salt. Okay, another example I can take Na2CO3 or CaCl2. Clear? And they ionize completely in the water, means forming cation and one anion like this: Na plus Cl minus, K plus Br minus, K plus Cl minus, here Na plus Cl3 2 minus, etc. Clear? So this we call as a simple salt. Second category come, that is mixed salt. Now what is the mixed salt? Mixed salt are one in which there is either two or more cation or two or more anion. If there is one cation, so there will be two or more anion. If there is two or more cation, then there will be one anion. Okay, so that kind of a salt we say as a mixed salt. So the salt which contain either one or more cation or anion. If there is one cation, suppose, then there are two anions, suppose, or if there is one anion, then there will be two or more cation. Then such a type of a salt we say as a mixed salt. So best example of mixed salt I can give you is bleaching powder. Bleaching powder means what, beta? CaOCl2. This is the bleaching powder. Now see here, when you drop it, it will form three kind of ion. One is Ca plus 2, OCl minus and Cl minus. Now see, here there are two anion and one cation. So this is an example of a mixed salt. Another example I can give you is microcosmic salt. Remember this, okay? This whole whatever I am writing, no? Sometime it can be asked in the competition also. Microcosmic salt. So what is the formula for this microcosmic salt? The formula is Na, NH4 HPO4 NH4HPO4 into 4H2O. When you drop it, it will form, see, this Na will form Na plus, NH4 plus and HPO4 minus. So these are the two. There are number of examples that are there. Just for your information, here I have written two examples of a mixed salt. So mixed salts are one which contain either one cation and one or more anion, or one or more cation and only one anion. So this kind of an example we say is a mixed salt. Example is, what is the example here? Bleaching powder and microcosmic salt. So types of salt, how many types of salt we have? We have 4 types of a salt. First is simple salt, another one is mixed salt, third one is double salt, and fourth one is coordinate salt or complex salt. These two we have to study in detail and we will understand here also. Simple salt means which are seeing at your home, no? Sodium carbonate and baking soda and table salt, and these all are complex salt, NaCl, KCl, okay, which have only one type of a cation, which have only one type of an anion. So that type of a salt we say as a simple salt. Another one is a mixed salt. So in a mixed salt are a salt in which if there is a one cation, then there will be one or more anion, or if there are one or more cation, then there will be only one anion. So such a type of a salt we say as a mixed salt. The best example is bleaching powder. If you see the bleaching powder and when you crack the bleaching powder, you will form Ca plus 2, OCl minus and Cl minus. So here you can see there are two anion. Similarly, a microcosmic salt, if you see the microcosmic salt, it is NaNH4 HPO4 into 4H2O. Yeah. So it will crack to form Na plus, NH4 plus and HPO4 minus. So here you can see it is there are two cation and there is only one anion. Clear? So now next we will go to the double salts. See here. Pause the video previously and you can write down, okay? See, double salts, in double salts are nothing but what? Here addition of salts takes place. What takes place? Addition of salts takes place. So here two or more salts combine together to form a double salt. Here two or more salts combine to form a double salt. There will be addition. Here number of cations will be there, number of anions will be there. That kind of a salt we say is a double salt. But the double salts are one which ionize completely when dissolved in water. When dissolved in water. They will ask this definition for the double salt. They will not ask what do you mean by double salt. Don't write down that when a two or more salt combine together to form a double salt. Yes, for understanding it's okay, good, clear. But actually the logic behind the double salt is what is meant by double salt and complex salt. The logic behind the double salt is when you dissolve the double salt in the water, it will ionize completely. How much? However, it will be having cation anion, it will liberate, take it, છોડી નાખે, જેટલા બી cation anion હોય બધા મૂકી દે, પાણીમાં જતા જ મૂકી દે. આ કોમ્પ્લેક્સ ના મૂકે, આ કોમ્પ્લેક્સ થોડું જ મૂકે, આ બધા મૂકી દેશે. જેટલા cation હશે, જેટલા anion હશે, બધા છોડી દેશે એક પછી એક. કોણ? ડબલ સોલ્ટ. કોમ્પ્લેક્સ સોલ્ટ એનું ઊંધું, બધાને છોડે, થોડાક મૂકશે, થોડાક નહીં મૂકે, થોડાક પોતે પાસે જ રાખશે. એને આપણે કહીશું કોમ્પ્લેક્સ સોલ્ટ. આગળ લઈ આવશે. So what do you mean by double salt? The double salts are one which ionize completely when dissolved in water. Whatever cation you have, whatever anion you have, when it is dissolved in the water, it will dissolve. It will ionize. It will show all the cation anion present in it. Clear? And these salts are formed nothing but what? When two or more salts are combining together to form a salt. Example, the best example is carnallite. Remember when I used to do S block and P block, at that time I have given certain minerals of certain elements. At that time we have done of carnallite. So example I will tell you here, best example is carnallite. First example, carnallite. The carnallite KCl, MgCl2 into 6H2O. Yes or no? Sorry, into 2H2O. Okay. when you dissolve this salt in water, it will liberate each and everything. It will liberate K plus, it will liberate Mg plus 2, it will liberate Cl minus. Any other is there? No. So whatever the cation and anion is present, whatever the cation and anion is present in that salt, if all the cation and anion are dissolved, are liberated, are released on dissolving, that type of a salt we say as a double salts. Another example I can give, that is Mohor salt. This we have not listening first time, okay, somewhere in a redox reaction I have done. Mohor salt, the formula of Mohor salt is FeSO4 NH4 twice SO4 into 6H2O. When this Mohor salt dissolve in water, it will form Fe plus 2, SO4 minus 2, NH4 plus. Any other you can see cation anion? No, these are only the cation anion present in it. See here, number whatever may be there. So whatever it will ionize completely, whatever cation anion is there, badda chodi muke hai, jao bhai, chutta. Another example I can give, that is alum. K2SO4, L2SO4 thrice into 24H2O. Water to emerge ratio 6H2O, but needed to show this. Okay, when you put this also in water, it will form K plus, it will form SO4 minus 2, it will form Al plus 3. Any other cation anion is seen? No. Whichever the cation anion is there in the salt, if on dissolving in the water, if it liberate completely, that type of a salt we say as a double salts. So this is an example of a double salts. So double salts are what? Double salts are one which ionize completely in the water. When ionized, it will show or it will liberate all of its cation and anion dissolve in water. Nothing will be kept within him. But that is not the same case with the complex salt. Complex salt is completely opposite of it. What can the definition of the complex salt? Double salt, complex salt are one which does not ionize completely when dissolved in water. I will tell you. Next point. See, in double salt, if I come, these are the addition of salt. See, this is one salt, this is also one salt. There two are added. See, so addition of salts, or the salt in which the double salts are the salts in which two or more salts are added to form a single molecule. See here also one salt FeSO4, another salt is NH4 twice SO4. Here also one salt K2SO4, L2SO4 plus 24H2O. So these are nothing but a double salts example. So double salt is one which ionize completely or which will show or which will liberate its all cation and anion which are with it. Completely ionized will take place. Complete ionized. Clear? Again once more, what are simple salt? Simple salt are one which contain only one type of a cation, only one type of a anion, and which also ionize. Mixed salt means what? Either one cation, then two or more anion, or two or more cation, one anion. So that type of a salt we say as a mixed salt. Double salt. So double salt are one which ionize completely in water, or double salts are the salt in which two or more different kind of a salt combined together to form a single unit. See, this is called a single unit. It's a magnesium ore. Clear? But here the definition of a double salt you should remember is the double salt is one which ionize completely in the water. Means whatever the constituent are there in the salt, each and every constituent will be shown by the double salt when dissolved in the water. Whatever the cation, whatever the anion, that will be shown. Nothing will be hidden, nothing will be joined, everything will be separated in separate ions and cations. So everything will be separated. Clear this part? So the best example is carnallite, Mohor salt and alum. Please remember this formula. Carnallite formula is KCl, MgCl2 and H2H2. When you dissolve in the water, you see there is a presence of K plus, here presence of Mg plus 2 and Cl minus. So this will get separate. Mohor salt Fe plus 2, SO4 2 minus NH4 plus, alum K plus, SO4 minus 2, L plus 3, everything will be separated. Clear this part? So this type of a theory are observed in the double salt. Written this, take a screenshot, then we'll go for the next. Next we'll come to our own topic, that is the coordinate salt or complex salt. Done now, man? Chalo. So what do you mean by complex salt, coordinate salt? It is opposite of a double salt. So this salt are one which do not get ionized completely in water. Or I can say there is a partial ionization, not complete ionization. See, example I will give you. The example, first example, very common which you have seen, that is K4 FeCN6. This is one complex salt. This complex, last class I told you, this complex entity should be written in the square bracket. This is a complex sphere, coordinate sphere. This is an ionization sphere. So this salt, when dissolved in the water, it will produce two ions. One is K plus, and here FeCN6 minus 4. See, this will not break it. This will not break. On ionizing, here Fe plus 2 or Cn minus will not be formed. This remain as it is. Means it retain its identity. It will not released. So this type of a salt we say as a complex salt. See in the previous section, previous slide if you see, I have shown NH carnallite. So in that carnallite K plus Mg plus 2 Cn minus everything is separated. Here Fe plus 2 Cn minus 6, if it was separated, then it will come in the double salt, but it is not a double salt, because here this identity which is in the square bracket remains as it is. Remains as it is. It will retain its property. It will retain its structure. It will not break it. So this kind of a salt we say is a complex salt. So here the ionization is complete or partial? Beta, partial. Why partial? This is not breaking. No. If this would have broken, I would have told those salt are one which get ionized completely. But here ionization is not completely. This is retaining as it is. This is remaining as it is. This sphere is coordinate sphere is remaining as it is. So such a type of a salt we say as a coordinate salt. Clear this part? Next example I can give you, that is, see you, this also somewhere we have done. See here. Remembering dark deep blue color when copper is dissolved in the ammonia solution in a copper when the when CuSO4 is when the ammonia is dissolved in the copper sulfate solution, when the ammonia is dissolved in the copper sulfate solution, it develops a dark blue color complex. That dark blue color complex is that. Understanding that, remembering in S block or somewhere D block we have done, no, that whenever the copper sulfate is reacted with the ammonia, it forms a dark deep blue color solution. This dark deep blue color solution indicating the complex so form of the copper. This is the complex. When I ionize this in the water, beta, SO4 will have minus 2 charge. This everyone knows this, no? SO4 minus 2 charge. So here minus 2, it will come plus 2. So CuNH3 4 plus 2. So this will be products obtained on ionizing. I will obtain this ion and this ion. See, this Cu is not separated, this NH3 is not separated, they remain as it is. Their identity remain as it is. They are not separating. They are not separating means here the ionization is partial, not completely. If Cu plus 2, NH3 also removed, SO4 also removed, then I will tell, oh, ionization is completely, but here ionization is not completely, only partial ionization taking place. This is the partial ionization. This is not separating, this is only separating. So this kind of a salt we say as a complex salt, and always the coordinates and the complex compound or coordination sphere is always maintained in the square bracket. So in short, the things which is in a square bracket cannot be broken. And that type of a salt we say as a complex salt, a coordination salt. So the things which is present in the square bracket cannot be broken. That type of a salt we say as a complex salt, coordinate salt. And the bond present between them is coordinate covalent bond. And this type of a complex is coordinate bonds, ligands, central metal atom, everything I have told in the last class. Yes or no? Yes or no? Clear? So these are the example of complex salt. One more example we will see. So that's it, enough. Okay. So you can write down these salts are one more definition, you write down this. For this you write down here, these salts are one which do not completely dissociate in water, which do not completely dissociate into water, which do not completely dissociate in water and retain its identity. And they retain its identity, means this identity is retained. Whatever was the property in the reactant, same the property will remain in the product, because this has not been broken, because this is complex. Clear? Now suppose if you want to break this, who can break this complex? Either highly acidic medium or basic medium or extreme heat can only break this complex. See beta, if you drink acid or if you drink base, you will die, no? When you are not able to withstand the acid and base of high proportion, then what is this complex? So if anyone is asking, no one will ask you this kind of a question, but if anyone is asking you, then how to break this complex? If you want to break this complex, then the medium should be highly acidic or highly acidic or high temperature can break this complex. Otherwise this complex cannot be broken. That's why this kind of a salt we say is a complex salt. Now write down here one more point. Write down one more point. These salts are one which do not completely dissociate. These salts are one which do not completely dissociate. These salts are one which do not completely dissociate in water, and these salts are one which do not completely dissociate in water and they always retain their identity and always they retain their identity. With who identity? This complex, this coordinate, this square bracket thing will retain their identity. Clear this part? So pause the video and write down if you want to write down something. Then I will move to the next topic, that is the classification of coordination compound. Write down this. So next topic we will see, that is classification of coordinate compound. Classification of coordinate compound. Now we will see this. Okay. So see, we can classify the compounds, coordinate compound, basis on two things. First, basis on the number of type of ligands, basis on ligands. And last class I have explained you what do you mean by ligands, and in the next class we will do the classification of ligands, which is very important. Okay. Second, we can see the basis on charge. Clear? So first we will see here basis on ligand. Clear? So we have again two types. One is homoleptic, another one is heteroleptic. It's easy, so don't worry about it. See beta, what do you mean by homoleptic? See, simple. If same type of ligand is associated to central metal atom in coordination sphere, it's a homoleptic complex. Example. See, first example, K4 Fe CN6. This is one complex, yes or no? This is the coordination sphere. In this coordination sphere, the central metal atom is iron and ligand is cyanide. If you see, same type of ligand is there. In coordination sphere, central atom is this, central metal atom is this, and we have a same type of a ligand. See, there is no other ligand here, only same type. So I can say this is an example of homoleptic. Another example I will go with CO CN6 minus 2. See, this is also one complex ion. See, central metal atom is cobalt. This is coordination sphere. You can see here same type of ligand is there, that is cyanide. Yes or no? Same type of ligand. Another example we will see. See here. This is one coordination sphere. This Mn is a central metal atom, manganese. And here we have a same type of a ligand, that is carbonyl. Oh, carbon monoxide means carbon. This is cobalt, beta. This is carbonyl, CO. Carbon monoxide also have a capacity to form a complex compound known as a carbonyls. So this is nothing but carbonyl. So you can see here in this coordination sphere, if you see, in coordination sphere if you observe, you will see that ligands associated to the central metal atom are of same type. See here. First, there are 6 cyanide, means there is only cyanide. There is no other ligand. Second also there is cyanide, no other ligand. And third is cobalt, carbonyl, there is no other ligand. One more example. CO NH3 6. I say here plus 3. See here this example. Yes or no? This is a one complex coordination sphere. Yes or no? This is a one ligand. So this ligand is associated to central metal atom. So same type of ligand is associated to the carbonyl. No different other type. If there is ammonia, only ammonia. Here only cyanide. Here also only cyanide. Carbonyl means only carbonyl. Ammonia means only ammonia. So this type of complex formed, we say as a homoleptic complex. So homoleptic coordination compound or homoleptic complex compound are one in which the same type of ligand or only one type of a ligand is associated to the central metal atom. One type only. Same type or one type. If one type of ligand, one type. Chalo na, one type. You can read the definition from a textbook. Okay, this all definition will be of your understanding definitions. So beta, heteroleptic will be what? Reverse of it. If two or more type of ligand associated to central metal atom in coordination sphere, it's an heteroleptic complex. Yes or no? Write down this first, then I'll go with this heteroleptic and then we'll see the examples. Take a screenshot. Chalo. Taken. Chalo, see here. See, now what can be the definition here? If more than or different type, or if I can write down here, if more than one type, or I can write down different type, one and same, no beta. If more than one type of ligand is associated by spelling mistake can occur, beta. Associated, if more than one type of a ligand is associated to central metal atom in a coordination sphere, it's known as heteroleptic complex. Yes or no? It's known as a what? Heteroleptic complex. If more than one type of a ligand is associated, see here same type, no, one type only. Cn means Cn. Cn means Cn, CO means CO, NSA means NSA. If here Cn also was there and some other also was there, heteroleptic. We'll see the examples. See here. I am roughing this part, okay. I hope we have done this, no? Example we will see. See, first example. Cu NH3 twice ClBr. See, this is one coordination sphere. Yes or no? See, the central metal atom is which? So central metal atom is copper. See the type of a ligand. There are more than one type ligand. Ligand 1 ammonia, ligand 2 chlorine, ligand 3 bromine. So if more than one type of ligand, this is more than one type, one is ammonia, chlorine, bromine. So if more than one type of ligand is associated to the central metal atom in the coordination sphere, is known as a heteroleptic. Now beta, this is the best example of an heteroleptic complex. Yes or no? See, this is a copper, which is central metal atom. Now this central metal atom is making coordination with how many ligands? 1, 2, 3 type of a ligand. So here there is not a single type of a ligand, more than one type of a ligand we have ammonia, we have a chlorine, we have a bromine. So this type of a complex we say as a heteroleptic complex. Clear this part? Next example we will see. Next example we will see. See this part. CO NH3 5 Cl into Cl3. See, this is one complex compound. See this coordination sphere. Central metal atom is cobalt. Central metal atom is what? Cobalt. Now to this cobalt, what is associated? There is one ligand is ammonia, another one ligand is chlorine. So different type of ligand is attached. See here. Another one example we can write down is CO NH3 4 Cl 2 plus 2. See here this. Now this is also one coordination sphere. See, this metal is cobalt, ligand 1 is ammonia, ligand 2 is chlorine. Another example I can give, that is Cr H2O4 Cl2 into Cl into 2H2O. See, this is your coordination sphere, square bracket. A square bracket is a coordination sphere. You can see there we have a central metal atom as chromium, and the ligands are, one ligand is water, there is neutral ligand that I will explain tomorrow. The one ligand is water, another ligand is chlorine. So there are different type of a ligand associated to the central metal atom. So this is an example of heteroleptic complex. Heteroleptic complex. Homo beta, same. A simple homogeneous mixture. A mixture in which all the constituents are completely mixed. Same, similar, same, uniform. Heterogeneous mixture, non-uniform. Similarly, this is non-uniform. Different type of ligands are there for the central metal atom. If you see there in the homoleptic complex, same type of ligand is there. Homo, same. Clear this part? So on basis on ligand, we can classify in this way, either homoleptic or heteroleptic. Now next we will go to the based on charge. Clear this part? Chalo. Done, no man? If you read from your textbook, more clarity will be there. Number of examples also will be there. As much as possible I am doing it, because I also have to cover the courses. If you have any doubt, please contact me, please message me. Clear this part? Chalo. Next is basis on charge. So simple, it can be positively charged, it can be negatively charged, and it can be neutral complexes. Or I will write down here on the top, so that I can give certain examples. Basis on charges, we can broadly classify into three. First is positive complex, second is negatively complex, and third is neutral complex. So as the name indicates, that positive complex means if there is a one complex compound, suppose if there is a one complex compound on ionizing, if the positive part is a complex, then such a complex is known as a positively charged complex. I will give you one example. See here. If I take this example, Cu NH3 4 SO4 beta. When I dissolve, it will get ionized. So it will form what? CuNH3 4 plus 2, and here it will form what? SO4 minus 2. Now on ionization, which charge is complex? Positively charged or negatively charged? So you can see the positive cation is a complex. So I will say this cationic complex, or positive complex, or I can say cationic complex. है ना? This I will say anionic complex, and this is neutral complex. So if any complex compound on ionizing, if the coordination entity, this coordination sphere has positive charge, then it's an cationic complex. If coordination sphere has negative charge, it's an anionic complex. Write down this. Chalo. First write down the cationic complex. Write down first cationic complex. Write down. Cationic complex is one. Cationic complex compound is one in which the complex compound on dissolving, it ionize and if in the ionization product the coordination sphere has positive charge, if the coordination sphere has positive charge, so this is coordination sphere. If the coordination sphere bear positive charge, then it's an cationic complex. है ना? So it should bear what? If you dissolve a complex compound, simple and shortcut I will give you. If you dissolve a complex compound, and when you dissolve, if you see the plus charge on the coordination sphere, on the complex coordination sphere, if you see the plus charge on this, then it's an cationic complex. Now if I take this K4 FeCN6, now when you dissolve in the water, what you will see? You will see K plus and you will see FeCN6 minus 4. Now where you see the negative charge? You see the coordination sphere is with negative charge. So this is anionic complex. So on dissolving the complex, if you see the positive charge on coordination sphere, this is coordination sphere, no? Square bracket means coordination sphere. If you see the positive charge on the coordination sphere, then it's a cationic complex. If you see the negative charge on the coordination sphere, it's an anionic complex. Clear? Write down. If the coordination sphere bear negative charge, next point write down. If the coordination sphere bears negative charge, then it's an anionic complex. Clear? Now if you take if you take complex compound and you will dissolve, if no charge, means they will not get separate. So that type of a complex we say as a neutral complex. If you take one complex compound and when you dissolve in the water, if they do not get separate, remains as it is, so we say as a neutral complex. The best example is carbonyl, nickel tetracarbonyl. This you know this. When you dissolve in the water, they remain as same it is. They remain as nickel tetracarbonyl only. So no charge is seen on dissolving, means they are neutral complex. So usually remember one thing, that carbon monoxide forms complex compound known as carbonyl, which are neutral. So 99, there are certain exceptions also are there, but 95% compound formed by carbonyl compounds are neutral compounds. And carbonyl compounds are of which compounds? Carbon monoxide compounds usually. So carbon monoxide forms a known as a compound known as a carbonyl compounds which are neutral. Clear? So when you dissolve in the water, you will see no charge on it. If you dissolve any complex compound in the water and if the plus charge is blinking on the coordination sphere, so that is an example of a cationic complex. If negative charge blink or appear on the coordination sphere, then that is an example of anionic complex. If no charge, neutral complex. Clear this part? Clear? So in this way we have to identify and classify the coordination compound. In the next class we will go with certain classification of ligands, then we will continue the classes. Thank you.